Oftentimes, heat gains and losses can be measured with a thermometer. When this is the case, the heat can be sensed, and we call it sensible heat. Raising the temperature of water from 40 degrees Fahrenheit to 60 degrees Fahrenheit is an example of sensible heat. The formula used to calculate the heat required to raise the temperature of an object is called the sensible heat equation, and is expressed as Q equals mc delta T, where Q is the heat quantity measured in BTUs, m is the mass measured in pounds, C is the specific heat of the substance measured in BTUs per pound degree Fahrenheit, and delta T is the temperature change measured in degrees Fahrenheit. The term delta is commonly used for different measurements. The triangle symbol is the character used in the Greek alphabet for the letter delta. The sensible heat equation can be applied anytime there is a change in temperature. Let's try an example.
Say we have 4 pounds of water and we want to heat that water from 30 degrees Fahrenheit all the way up to 50 degrees Fahrenheit. This is perfect for the sensible heat equation since we're dealing with the change in temperature. So I'll write my equation, Q equals mc delta T. And we have everything we need to solve for Q. We know our mass is 4 pounds. The specific heat of water is something we need to know, which is 1 BTU per pound degree Fahrenheit. And our delta T is the difference between the final temperature and the starting temperature, which is 20 degrees. We'll plug our numbers in. We find out that Q equals 4 pounds times 1 BTU per pound degree Fahrenheit times 20 degrees Fahrenheit. Just notice our units will cancel and we'll be left with BTUs. 4 times 1 is 4. 4 times 20 equals 80. So it would take 80 BTUs to heat 4 pounds of water from 30 to 50 degrees. In this example, we're given the exact same parameters except for instead of heating up water, we're heating up a piece of iron, 4 pounds of iron from 30 degrees up to 50 degrees. Again, we'll apply the sensible heat equation since we're dealing with the change in temperature. So Q equals mc delta T. Our M is the same, 4 pounds. Delta T is the same, 20 degrees. The specific heat's what's changed. You would be given this in the problem, and it's in this case 0.118 BTUs per pound. So Q equals 4 pounds times 0.118 BTUs per pound degree Fahrenheit. And the change in temperature is still 20 degrees, just like it was in the water example. Now, we can't quite do this in our head, so we grab our calculator. 4 times 0.118 times 20, and we learned that it would take 9.44 BTUs to heat iron. Quite a bit easier than heating the water. All right, let's do a third and final example. In this example, we're told that we have 2 pounds of some unknown substance, and it takes 100 BTUs to raise the temperature of that substance by 25 degrees. So now we know our BTUs, we know our mass, and we know our temperature change, but what we don't know is what the substance is or its specific heat. So we're asked to find what is the specific heat of this unknown substance. Since we're dealing with the temperature change, we are going to apply the sensible heat equation. Q equals mc delta T. So we want to solve for C. So whatever I do to one side of the equation, I must do to the other to get C all by itself. So I'm going to divide both sides by m delta T. M delta T. Then we find that Q over m delta T equals C. Now we have the equation like we want it. We just need to plug in our numbers. Let's go ahead and do that. So we have 100 BTUs. Divide that by the mass, which I said was 2 pounds, and the delta T, which is 25 degrees Fahrenheit. You plug that in your calculator, or maybe you can see 2 times 25 is 50, so 100 divided by 50 is going to be 2 BTUs per pound degree Fahrenheit. That is the specific heat of our unknown substance.